One of the primary thing that I wanted to start with was Crystalline. I'm not sure who or if anybody has heard of Crystalline. It's been around for quite some time. And we're faced with a lot of challenges with concrete today. It's not what it was 30, 40 years ago, as we know. And when we look at some of our building assets, the concrete is continuously deteriorating, and some of those things that are causing the reduction in the lifespan of concrete is water, our freeze-thaw cycle. So we know that water gets into the pores. The concrete is very, very porous. So it gets into the capillaries and the pores of the concrete. We get a freeze-thaw cycle. It expands, and we all know what happens from there. And if it's a structure that is a condo corporation, when it's time to restore that underground parking garage, the burden goes on to the condo owners, as we all know. So it's been evaluated, it's been assessed that they're saying that in Canada alone, $75 billion is spent on restoration of structures, whether it be a condo or tunnels or that type of thing. And we know that with the cost of those huge construction projects today, it's a huge burden. So we had to come up with something that was going to be a little innovative, that was going to be something for the future. And this has been around for a long time. Initially, Crystalline was invented by the military. They needed something for military bunkers. Can you imagine having a 12 to 24-inch slab, concrete slab, inside of a mountain, protecting, the military, if you will, and all of a sudden, the waterproofing membrane starts to deteriorate. What do? Do you excavate the mountain? You can't do it from the top side, so you needed something from the negative side. The product that we're using primarily is, there's several different Crystalline companies out there. The one that we're using is CN2000. It's distributed by Kelso Coatings. We are an exclusive applicator and distributor of Kelso Coating. And so essentially Crystalline is formed of millions of little microscopic crystalline gels. And what they do is they start to form to the concrete. They start to become part of the matrix of the concrete, if you will. So it's applied in a 3-step process. It cures within 24 hours, but it continues to grow and morph to the concrete structure for the life of the concrete, provided that there's moisture. Meaning, so if we apply to a crack, you've got a crack on a substrate somewhere, and all of a sudden there's water that's leaking. We apply the product. It cures within 24 hours and it continues to morph. Once there's no presence of water, the product goes dormant. And it can do that for 2, 3, 10 years until water is reintroduced. The next freeze-thaw cycle, you get a crack that's reintroduced and water is reintroduced. So therefore, it reactivates the product and starts to morph from there. This is an example here, typical concrete structure with moisture that's permeating through the pores and the capillaries. The next one here shows the Crystalline that's been applied to the negative side, so the inside of your structure. You didn't have to have all the burdens of excavating, the overburden that's on top of picture a TTC tunnel. We've done some work at TTC as well. Picture excavating the streets and the cost that would be associated. They needed something to go in from underneath. We did testing for 2.5 years with TTC to have the product approved to see that it was viable, that it would make sense and it would work. Also, the product has been funded by NSERC. They recognize, the Canadian government recognized that concrete is just, like I said a while ago, not where it was 30 years ago. So we need something to be able to do it from the negative side, therefore, and to reduce some of those overall costs. Queen's University took a particular interest to this. So the government gave the Queen's University $250,000 and said, test the product. We want to know what the limitations are, if there are any, and we want to know how efficient it is, how effective it is. So they were so impressed that at the end of their testing, they gave them an additional $200,000 and said, continue testing the product in different applications and different scenarios, if you will. So we're very proud of that. That's available at any time for customers as well. What is the benefit of Crystalline, of doing it from the negative side? Besides cost, it continues to self-heal. So like I alluded to a while ago, so once you've repaired, does everybody remember the old injections where they do the crack injection using a polyurethane or an epoxy-based product? It's a technology that's been around for a long time. Still works, has limitations, of course. It's a rigid product. So once that crack is repaired, wonderful. But we go through freeze-thaw cycles, concrete moves. So once it continues to crack or has another crack, water comes back in, what do you do then? You have to call the people back and get it done again. So Crystalline is self-healing, meaning if there's a pinhole, even a pinhole in the existing repair that you did, or another crack is introduced, it reactivates the Crystalline and it starts to heal. The yield will go up to 24 inches. I mean, there's not a lot of structures that are 24 inches thick, but it will, however, go all the way to the other side. But more so, what's more important is it minimizes the inconveniences of putting a large project together to start excavating and looking at a 4 or 5 year phased project to re-waterproof the soffit of your underground parking, if you will. Here's a few examples of, we've worked with almost every property manager or property management company in the GTA and throughout Canada. But here's a few examples of some of them. A lot of them are underground parking. I wanted to focus more so on that, particularly for this show. City of Toronto, not far from here, Queens Quay. So this has been down since 2014, and you can imagine the hydrostatic pressure coming from the lake. And we're glad to say that we've gone there 3 or 4 more times to do additional work. Never had a leaking problem, knock on wood. Metrolinx, so Go Transit, TTC, as I mentioned a while ago, same thing. You know, I mean, there's a lot of pressure that's coming from either the rail system and whatnot. So again, we're able to stop the water. Oxford, here's an example of a tunnel leading to the garage. We've all seen these marks. We know that the brown is obviously the corrosion from the rebar. One of the other benefits as well is that once the crystalline has started to form within the concrete, it envelops the rebar and it coats it to stop, at least slow down the corrosion process. Similar to what an anode would do when they did the initial pour. That's a TTC underground as well. In the interest of time, I'm going to speed through a little bit. I'm going to have Boris come up shortly. Billy Bishop Airport, we're all familiar with the airport. There's a lot of water, obviously, on the soffit. And again, we were successful in doing a lot of the waterproofing there. We just finished a large project with the Panama Canal. You can appreciate what the hydrostatic pressure would be there. Three Gorges Dam. We've worked with, you're very familiar, some of you, I've actually recognized a couple people, so we've worked with some of the engineering firms that are speccing our product that have been approved. One of the hardest entities to approve, which Boris will talk about, is MTO, and the product for the expansion joint is approved with the MTO. Here's a small list of some of our customers that we've worked with. And now I'm going to introduce to you Boris. Boris is with Polyforce, one of our partners. So for us to have this solution of being able to repair the concrete from underneath, we need to have a way to address the expansion joint. So Boris will talk to you a little bit about the expansion joint now. And thank you very much.
Thank you very much for coming. My name is Boris. Jack and I and a few other companies are working together as partnership and in collaboration to resolve various problems that concrete, parking garage, condo, industrial, and many other structures that have one thing in common: they're made of concrete. All the problems that they have. As Jack was saying, mainly the problem with concrete structures is that it's made to fail. And I know that might sound absurd, but that's kind of is true. Because concrete back in the day was made that it has pores, so it stands longer and it's has better carrying capacity. But now that it has pores, the water permeates the concrete and it starts to degrade it over time. So Crystalline is a product that is like an anchor that goes into the concrete and makes the concrete denser in order to stop the waterproof, enhance the waterproofing qualities. There is a product made by Polyforce, and Polyforce owns Joint Seal Waterproofing. I represent both. That mainly focuses on two aspects of remediation of leaks. One aspect is expansion joint, and the other one is physical fixing, restoring carrying capacity, loads, and the rest of it. Expansion joint is nothing more than a gap between two concrete slabs left there in order for those slabs to expand and contract. There's no secret about it. Every parking garage has it. Every bridge has it. Anything made of concrete has it. Even sidewalks, those cuts that you see are made in there in order that the sidewalk in entirety doesn't crack. The problem with expansion joint is very simple. There is a gap between two concrete slabs. Water goes through, and the concrete starts to degrade. So anytime you're in a parking garage, if you look right above your head, you're standing on 32,000 per stall property, where the water is leaking not on the floor, but the ceiling itself is getting destroyed. And I'm not even talking about ramps and other things that are even more expensive. And you try to get someone to do the paving, and they do it, and it doesn't leak for a while. But then after that, when you remove what was applied in there, usually it's a membrane type application, you realize that your concrete is degraded even more. So what do? You either demolish it or you patch it again, and then either it's going to be someone else's problem or it's going to be yours, but much bigger problem down the road. So in order to fix that, we are doing concrete injections right into the expansion joint. It's a very new thing to do. As far as I know, nobody else does it but us. And the biggest benefit from it is that if your concrete is leaking, that's because the membrane over the top of your concrete has failed. So what's a logical thing to do that you all been doing? Go upstairs and fix the membrane. The only problem with that is that you have vegetation and structures and everything else on top of your parking garage. So 90% of your cost is actually removing everything up on top and then repairing the membrane and then resurfacing the whole thing, and you stop the leak. Actually, from experience, we know that a lot of times you fix the problem where you thought the membrane failed, and then you patch it all up and the leak happens again, and that tells you that it failed in two places, or at least there is another place that still needs remediation, so you do the same thing over again. What we do, we install a rubber insert. It's very nicely finished, doesn't need any kind of painting, right into the slab, into the ceiling between the two concrete slabs, and then we put injection port and we inject the liquid, and it's as liquid as water. We inject the liquid right into the expansion joint. This will stop it from leaking out while it's curing. After it has cured, it turns into a jello-like, very soft rubber that has ridiculous adhesion to concrete. It expands with expansion joint and contracts along with it. Hence, the geometry of the piece you're looking at is made for exact same thing. So if you're looking at the project where you're fixing a parking garage that you have to do top and the bottom, with this solution, you only do the bottom. Another important aspect of it is that typically you do caulking in order to stop water from going through. In effect, you're actually making a bad thing worse, because if I were only to insert the rubber piece into expansion joint, you wouldn't see water for a long time. I promise you, for 5 years, you wouldn't have any leaks. But we all realize that if you had a leak there, the water will accumulate anywhere where I have the yellow part now, and it's gonna go into the concrete and it will destroy it completely. From 1-inch expansion joint, you're gonna end up with 5 or a foot of expansion joint, simply because there's no concrete to speak of anymore. And that all happens in 5 years. So there is barely anything, and then the whole thing is gone. By filling the whole void with soft rubber, what you're achieving you're not only removing the water that you might have had there, it does displace the water, but you're also going out into your membrane, ensuring that all the cracks and areas that led to the leak are filled. We did this with TTC tunnels, we did this with a lot of parking garages, and the technology is always the same. Application might be different, but more or less same thing. So moving on, we're doing general parking repairs. We do a lot of tunnels. Like Jack was saying, sometimes you don't have a luxury of removing on the positive side because it's a tunnel. So you cannot dig around the tunnel, so you have to go from the inside. When we were injecting the tunnel, the leak was around the rings. By injecting in the area where it was leaking, we noticed that the material along with the water actually started seeping out 10 feet away. And it's a beautiful thing, because if I fixed one ring, the next would leak. I fixed another, the next would leak, and so on and so forth. So it's a permanent solution where all of the voids and all the water you might have had there is completely removed. And you actually saw the water leaking out from all kinds of places, and after that, rubber followed along with it. So it really truly is a long-lasting solution that I can look you honestly in the eyes and say it really works. We not only produce the material, we apply it, we engineer it, third party tests it, so we handle it from the very beginning to the very end. Typical parking garage, you've got the pressure cooker, I call it, vessel with lots of pressure and the liquid inside of it, and down the tube it goes into the ceiling. In this case, we're patching not an expansion joint, but the ledge between the wall and the ceiling. And a lot of times you will see leaks around the column, or that big thing that sticks away from the column called the ledge beam, and it's leaking. And if you clog it, you'll destroy the ledge beam, I promise you, although it's going to happen in 5 years. So that's the fixing we're doing as well. So type of a ledge beam application, that's what it looks like after. Rubber was not required because there is no movement. It's just one slab line on top of another. You want to seal it. You want to make sure it's soft so it doesn't destroy itself. Simple reason we don't put diamonds in our teeth is because next time we buy, there won't be a tooth. There will be a diamond. We do repairs of columns. Now, when you're repairing columns, the problem is not only the leak, but the column was put in there for a reason. It's the same thing as taking something apart and putting it back together and having spare parts. That's not a good thing. So when your column fails, not only you want to make sure that it looks and doesn't leak the way that it used to be, but also that you restore the carrying capacity of the column, because that's mainly why the column was there. So by applying same soft rubberized liquid material into the joint itself, we also do the outside column fixing together with Crystalline and also with Polyforce Plus, which we're going to talk about in a second, in order to restore the carrying capacity of the column as well as waterproofing it. So it's Anna's day job in the end. We do traffic topping with another material called Polyforce Plus. I just mentioned it a second ago. It is 85 MPa. It's not a mistake. It really is that strong. But at the same time, I was giving you an example of a diamond. Polyforce Plus is elastic. When you squeeze it, it doesn't crack. It just changes the shape a little bit. And another most important part is that when you apply it on metal or concrete, not only it has enough adhesion to become monolithic with the surface you apply it on, it will also expand and contract with a concrete or steel surface. So we did certify it with MTA. It is something that we use for structural repairs. It's something that we use for waterproofing as well. It has been tested in freeze and thaw for 300 cycles, equivalent to 25 years. And this is why we proudly say that it does have useful life 25 years. We actually had zero degradation. And I stopped the testing because 300 is already too much. So after 25 years, it'll actually be the same way you applied it according to the test. Beyond that, well, it's too long to test. 1.85 MPa of adhesive strength. So when you glue something and you try to rip it off, that's 1.85. If I were to take concrete and try to rip it apart, I only need 1.2 MPa of strength. Meaning that when I glue this little block piece to a concrete and I try to rip it off, the only time it will come off if the concrete itself fails, which is already absurd because you're not going to do that. We do restoration of columns, like I said. We do restoration of ledge beams along with it. We also restored, oh, I'm going back, I'm sorry. TTC tunnel. So we do floor restoration. This is after patching, we just shave it, and that's what it looks like. All the cracks were filled, and you leave it at that. If you want a membrane on top of it, be my guest, but you don't have to do that. Staircase. Now, everybody has staircases, and everybody has this horror that they're going to wake up one morning and one of the tenants or someone slipped and fell on it, and you're faced with a situation where you can't actually restore a staircase because you need minimum 2 inches of thickness of concrete, and removing the staircase altogether also becomes a problem because not always you can do it. With Polyforce Plus, we can remove all that rubbish that used to be there, shave it, and restore a geometry. Actually, this surface is 85 MPa. When this was new, it was only 25. This will last a lot longer. The cost of it, be my, you make your best guess, but it's a lot less than removing the whole thing altogether. Same thing happens with balcony. You remove part of the balcony, you try to glue the old concrete on top of it, you go like this on it, and the whole thing falls. So what do people do? They inject rods into the balcony, and they make sure that the rods embedded into the balcony are holding the other piece. Not the adhesion between the old concrete and new, which the way it should have been done, but just the geometry. Our adhesion allows us to make sure that the whole slab becomes a monolithic slab that will stand the test of time. This pedestrian bridge was actually written off by City of Vaughan because it was unsafe. It's still in use and looks beautiful. Elevator shaft, same thing. You cannot go on a positive side. It's elevator shaft. There string of elevator shaft we've done in Toronto, south of Front Street. A lot of buildings went up, water table went up, buildings are getting flooded. They're actually standing in a pool of water. We do the application from the inside. Crystalline is a beautiful application for it because it's going to go into the concrete and restore it. Then after that, we put Polyforce Plus, and if you have any kind of joints, we do the Polyforce Flex on it. And that's the end of the presentation, and thank you very much.